8.2 example 4 in Math 30-1. It wants us to actually use some kind of a logarithmic function to solve something. And I now and again, or every time we solve a problem like that, it's important to remember what the variables mean. And it tells us that n is equal to, I got to find it here, the filter shade number. So I'll put shade number there. And maybe I'll underline it in the block. So it says the filter shade number n is defined by the function. It gives us the function. And then finally, it says that t is the fraction of visible light. Visible light. All right, so it says that shade numbers range from 2 to 4, so that's important. That gives us the domain of the function. It says a shade number of 12 is suggested for arc welding. What fraction of visible light is passed through the filter of the welder as a percent to the nearest 10,000th? Now, the one thing I would like to do with this function, just to make it a little bit clearer, I think, is I'm going to write in function notation. And n as a function of t, which is the fraction of visible light, is given as, and I'm going to clean that up a little bit, I'm going to write it as -7/3 times log t plus 1. And then what's really important about this is we have to remember what base our logarithm is. Because a base was not given to us, our default, or what we assume, is that it's base 10. And assume's the wrong word. It is base 10 because no base is written. So what this question is really trying to get us to answer, it says that a shade number 12 is suggested for arc welding. It is telling us that n of t is equal to 12. And what it wants to know is what value of t, what fraction of visible light would that shade number, 12 let through. And if we look at that algebraically, then it's saying that 12 is equal to -7/3 times log t plus 1, and we have to solve for capital T. The one mistake that students make again and again is before you switch to exponential form, you have to bare minimum get your log, the log of t or log of whatever, isolated on one side. So that's the first thing that we're going to do. Before I do anything else, I'm going to subtract 1 from both sides. It's going to give me that 11 is equal to -7/3 times the log of capital T. I'm going to get rid of that denominator by multiplying both sides by 3. So 33 is equal to -7 times log T. I'm going to divide by -7. Again, I'm just going to go to the right here. 33/7 is equal to the log base 10 of T. Now, once we get to this form, switching to exponential form is your best bet. But to try to make it a little bit clear as to what I'm doing, I am going to write that base 10 in. And if the value is -33/7, then the base to the power of the value is equal to the argument of the logarithm. And they actually do us a very big favor here. There's no more manipulation required. And what you have to get used to is the inside, or the argument of the logarithm, isn't always just going to be the variable. What if it was, t plus 5? What I would do is switch to exponential form and then solve the non-logarithmic equation from there. And we're going to see that in much, much more detail in 8.3 when we truly get into, kind of using logs in algebra to solve exponential functions. From here, though, I would type that into my calculator, being really careful with putting my exponent in brackets. And again, it's a bit of an ugly number. It's 1.930697729 times 10 to the -5 is equal to t. I'm going to switch that into normal form, and that's 0.1234193069779 is equal to t. Now, that's a very, very small number, but you really have to remember what this is representing. Oh, it says as a percent. Sorry about that. This is not a percent. This is a decimal. The way we switch from decimal to percent is we multiply by 100. So this is 0.001930697%. It wants it to the nearest thousandth. So that's 0.002%. Now, that is an absurdly small number. And it's good that it's that small, because when you're welding, if you're getting all that light entering, you are literally going to burn your retina. So those welders, shades allow us to look at, extremely bright lights. If you want to look at a solar eclipse, you can use a high enough welder shade because it lets in such a small fraction of visible light that you won't get that eye damage. Please don't look at the sun directly just to test if I'm right or not. It's not a good idea, and certainly you should never look at a solar eclipse without a pinhole telescope or a welder shade, or there's certainly some other stuff available online. So I'm going to put the standard assignment up for 8.2 there. Make sure you are chipping away at it. Check Google Classroom for any modified assignments and keep practicing because we're almost done and we just got to get it to that finish line.